Hello, scholars. Ode Agbaka Godwin here again. So if you haven't liked, shared, commented, or subscribed to this channel, please endeavor to do so. Please. Thank you. Now we have an interesting episode. The topic for today: measure of central tendency. But sorry to burst your bubble, sociologists. Most times we feel our course is a free-for-all and we don't need to do anything that's related or affiliated to calculations. But that's wrong. As a sociologist, in order for you to carry out your researches, you need to have an understanding of data analysis. So that's why we're treating arithmetic mean today. So the arithmetic mean, also known as the average or mean, is a statistical measure that calculates the central tendency of a set of numbers. Now, the calculations, right? To find the arithmetic mean, you need to add up all the numbers in the data set and you divide by the total count of numbers. That is, the arithmetic mean is equal to the sum of numbers divided by the total count of numbers. Now, in the real world, arithmetic mean applies to different fields or profession. In finance, for instance, the average stock prices, returns, or portfolio performances. In education, in calculating students' grade, test scores, or attendance rate. In healthcare, average patient recovery time, disease prevalence or medication efficacy, and even in businesses too. So your sales average, your customer satisfaction scores, or employee performance rating. And we have different types of mean. So we have the simple arithmetic mean, in which we're treating right here, right, is calculated for a single data set. Then the weighted arithmetic mean, in which we're going to treat later, it accounts for varying weight or importance of values. The geometric mean too, which is suitable for growth rate, returns, or ratios, and even the harmonic mean too. So the arithmetic mean, as I've said, also known as the mean, is the most commonly used, right? It is. So I just want you all to have a full grasp of what arithmetic mean is all about, because it is important. You're not going to run from calculations as a sociologist. So have that at the back of your minds. So arithmetic mean and statistic itself are very crucial in sociology for analyzing, understanding, and interpreting your data or any social phenomenon. So for instance, in research and analysis, let's talk about like data analysis. Statistical measures like arithmetic mean help sociologists to summarize and describe large data sets, revealing patterns and trends. Even in comparative studies, it means like it enables comparison across different groups, your regions, time period, and it highlights the difference and similarities between those groups, right? Now, arithmetic mean is denoted by the symbol X bar. So you can see the way I'm writing the formula right there. That is summation xi. I is equals to 1. That is your X bar, right? Divided by n. Your n is the number of observation. So where your E, right, is equal to summation. We can see that, right? Now, in terms of social understanding, in demographic insight, even in social inequality, statistics actually reveals the disparity in wealth, in health and opportunities, and etc. Now, back to what we're actually treating. Our X bar, right, is equal to our sample arithmetical mean, as we can see, right? So, and when we go further, as I've said, the n itself in small letter is the total number of observation. So they're going to give you your observation, you need to calculate it. So we have a question right here. If the number of students a lecturer is supervising for project work are 21, 19, 23, 27, 24, and the lecturer's age is 33, calculate the mean. It's very simple. The first thing we're meant to do is to write out the number of observation. Right. So we count all the numbers right there. That is 21, 19, 23, 27, 24, and 33. So we notice that n in brackets, which is the number of observation, is equals to 6. That is the first step. we're getting there. Okay, then the next thing we're meant to do is to write out the sum of observation. Now, what is the sum of observation? We add everything up together, right? So, and that is denoted by the sign in which I've written there. That is the summation xi. Now, the x bar is equal to add everything, sum everything up, 21 plus 19 plus 23 plus 27 plus 24 plus 33. Now, divided by the number of observation, which is 6. That's the 6 up there. That is it, number of observation. Now, when we use our calculator to add everything up, a summation of everything divided by 6, that is 21, 19 plus 23, 27 plus 24 plus 33, divided by 6, we're going to have 24.5 years as our final answer. Easy peasy. And that's the answer. It's funny how I actually term this rough calculation. So we want to solve this without using our calculator. That is, for instance, if your calculator is not readily available. So we add everything manually. 21 plus 19 plus 23 plus 27 plus 24, then plus 33. Sum everything up together, starting from your right hand side. So 1 plus 9 is 10, 10 plus 3 is 13, 13 plus 7 is 20, 20 plus 4 is 24, 24 plus 3 is 27. So we write 7 down, then take the 2 up there. Write it up. Now, this is what we do. 2 plus 2 is 4. 4 plus 1 is 5. 5 plus 2 is 7. 7 plus 2 is 9. 9 plus 2 is 11. 11 plus 3 is 14. So when we add everything up, we notice that it is going to give us 147. Our answer right here, when we add it up, is 147. Now, 147 divided by 6, it's going to give us 24.5 years. So we can see that the answers, they actually tallying. They're in tandem. So we have another question right here, which is find the mean of the following. That is 1 or number 1 over 4, 2 or number 1 over 2, 5 or number 1 over 2, 3 or number 1 over 4, and 2 or number 1 over 2. The first thing you're meant to do is to write out the number of observation. So when we count all these numbers, we can see that the number of observation, they're actually 5, right? So your n in bracket is equals to 5. Easy peasy. We can see it's very simple. And then the next thing you're meant to do, since this is in mixed fraction, right? So you change it from mixed fraction to improper fraction. You can either use your board mass to solve this, or you can change it to a decimal point if you're using your calculator, right? So now when we do that, we'll notice that 1 times 4 is 4. 4 plus 1, right, is equal to 5 over 4. So we've changed it from mixed to improper. 5 over 4. Then 2 times 2 is 4. 4 plus 1, 5 over 2. Plus 5 times 2 is 10. 10 plus 1, 11 over 2. Plus 3 times 4 is 12. 12 plus 1, 13 over 4. Plus 2 times 2 is 4. 4 plus 1, 5 over 2. Now we've changed it to improper fraction. Now we write out our formula, which is equals to summation xi over n. Simple. So we need to be clear about that. Now, when you convert the improper fraction to decimal point, you have 1.25 plus 2.5 plus 5.5 plus 3.25 plus 2.5 divided by your number of observation, which is 5. So when you use your calculator, you add all the numbers. That is 1.25 plus 2.5 plus 5.5 plus 3.25 plus 2.5 is equal to 15 over 5, which gives you 3. So our mean right here is equal to 3.